The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Number 3 says, what mass of oxalic acid, H2C2O4, is required to make 250 mils of a 0.05 molar solution? Alright, we're looking for the mass of oxalic acid, and we're given the volume of solution. Ooh, that's important. Of solution. Okay. And what molarity is the solution? It's supposed to be 0.05 molar. What does that big M mean? Well, we know it relates to the concentration of the solution. So it's how much stuff is in there per volume. If I have my water bottle, Jake, how concentrated is your sweet tea? Oh, it's super sweet. There is so much sugar per liter of solution. So that would have many moles of sugar per 1 liter solution. The higher the molarity, the more concentrated my sweet tea. Let's decompose this molarity. 0.0500 molar. This big M means moles of solute divided by liters of solution, divided by 1 liter of solution. Right? In this case, solute is going to be the oxalic acid we're looking for. So H2C2O4. Great. Alright, so we were given one ratio as an unknown. This is the concentration. Same as this. And we were also given one number without a ratio. This is usually the number you start out with in the problem. So we're going to start out with that. 250 mils of solution. Good. You have to read the problem carefully to find out this is actually supposed to be solution here. It can't just be mils of nothing, it has to be mils of something. And it's not oxalic acid, it's mils of solution, which contains the oxalic acid, but plus like water, whatever it is. It was used to dilute the oxalic acid. Alright, so now what do? Well, we're going to have to convert. But do we just jump straight into this? Not quite, because I can't cancel mils solution with liter solution. So I need to put mils solution down here to cancel these mils solution. And then I'm going to put liter solution up here so that later I can cancel liter solution and eventually get to moles. So what's this ratio? I know that there are 1,000 mils solution per 1 liter solution. And so now I'm in liter solution. I need to cancel liters with by using this ratio. So I'm going to have moles at the top, H2C2O4. See how I'm getting closer and closer to eventually getting the mass of oxalic acid. Once I'm at moles, I can just easily convert to grams. So what's this ratio? I have 1 liter solution per 0.0500 moles oxalic acid. Liters cancel. And now I'm continuing the conversion. I have moles, so I need to put moles on bottom. Moles of H2C2O4. Okay. And then what do I need up top? I'm looking for grams of oxalic acid, ultimately. C2O4. Do I know this ratio? Do I know how many grams are in 1 mole of oxalic acid? Oh, in fact I do. How do I do that? I look at my periodic table and I say, for each hydrogen, there's 1 gram per 1 mole. For each carbon, there's 12 grams per 1 mole. For each oxygen, 16. Right? You guys know how to do that. So the molar mass is 90.0354. You don't have to be too exact. The more digits you carry over, the more exact your answer. But many people estimate, it's okay, it's alright. So you punch all this out, because moles of oxalic acid cancels, and we're left with grams. Punch all this out, and the answer comes out to be 1.13 grams of oxalic acid. All done. I want to highlight the importance of putting down your knowns down here, because this is all the information that you're allowed to use, pretty much. Sometimes you won't even use all the information, but it helps to get rid of the extra text that is very confusing.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.